So the next video from chapter 8 is going to cover potential energy and gravitational potential energy near the Earth's surface. And this is chapter 8-2 and 8-3 from the textbook. Okay, so last video we talked about energy, which just described the state of a system, and kinetic energy, which was the energy of motion. So now we're going to talk about potential energy. And potential energy, so we use a U to stand for potential energy, naturally. And this depends on the configuration of the system, so the location of the objects in your system. So in general, the change in kinetic energy, right, so delta U, well, remember delta anything is just final minus initial, so U final minus U initial, and the way you calculate a change in potential energy is in general you need to do an integral. So when you're doing the integral of a force over a distance. So in the way this is written, so here we're assuming that our object only moves in the x direction. So we need to take the component of the force in the x direction and integrate over the distance from the final location to the initial location to the final location. So in general, that's how you define potential energy. An important thing to remember, so potential energy is tied to the force between two objects. So since forces always involve two objects, you have to include both of them. Remember, we like to think of this as the source of the force and the subject of the force. So both of these must be in your system for this to make sense. And also, potential energy can only be defined for conservative forces. So far, the forces we've looked at, gravity and the spring force, are conservative forces, whereas things like friction and drag forces like air resistance are non-conservative. So for these sorts of friction and drag force, they're sometimes called dissipative forces. You can't define a potential energy. So we'll actually have to wait till next chapter to learn how to deal with those. So by definition, potential energy only depends on your initial position and your final position. It does not depend on the path traveled. So in fact, that's one way you can define a conservative force, whether that's true or not. So in general, this has to be true for potential energy, only depends on initial and final positions, doesn't depend on whether you went a straight line from point A to point B or if you went on some other path from point A to B. It only depends on the initial and final positions. So another important thing to remember, so the way this is defined, only changes in potential energy are meaningful. And we can actually see an example of this. So gravitational potential energy, and in general, this is true for any sort of potential energy. We need to decide on a coordinate system, or your book calls this a reference configuration. And essentially what you're doing there is you're defining the point where the potential energy is zero. So for example, let's start off in the easiest case. So let's say we're near the surface of the Earth. And near the surface of the Earth, of course, the acceleration due to gravity or the force due to gravity is constant. So if that's the case, well then according to the formula from the last slide, the change in potential energy, we need to do this integral of force over a distance. And again, well, since I'm assuming this is a vertical distance instead of x, I'm using y here. But near the surface of the Earth, the force is just the force of gravity, and the force of gravity is m times g downward, so that's where the minus sign comes from. And well, then you do you take the antiderivative of mg, and you just get mg. And we evaluate this at a final and an initial position. So typically for your reference configuration, the easiest thing to do is you'd say, okay, well, my potential energy is going to be 0 at y equals 0. So if you do that, then this gravitational potential energy, so U sub g, is the mass of the object times the acceleration due to gravity times the vertical location y. And we do have some freedom actually in choosing exactly where we want to put y equals 0. But in general, when you have a choice in coordinate systems, you always want to pick something that's going to make your life easier rather than harder.